It's ethene, C2H6. Middle is the alkene butene, C4H8, and the end was an alkane propane, C3H8. And what do they all have in common? They are made of carbon and hydrogen. Which molecules react using addition? Now technically we haven't done it yet, but from Monday's lesson you should be able to figure it out that it would have to be the alkene, because alkanes are not reactive. And the general formula we did was CnH2n. Okay, so everything was relatively straightforward there. It then asked you to draw some structures. So 21.3 was pent-1ene, B was pent-2ene, C was 2-ethyl pent-1ene. So just make sure you have the right amount of bonds specifically coming out of these carbons. Okay, so we've said every carbon can only have 4 lines coming out from it. Thumbs up to go forward. Thanking you. Okay, the last one of this was a 2-methyl but-2-ene. Okay, Julie, you okay? Alright, so then 21.4 you had to draw from the name. So we'll leave these up. So cyclohexene, you had to have 1 double bond in it because it had an alkene name. So for C, it actually doesn't matter if you were going from the left or the right, it's the same diagram, no matter what. Happy to move? Thank you very much. Then for the last one, saturated only contains single covalent bonds. Aliphatic is either straight chain, branched, or non-benzene ring. We've done this before. Alkanes, general formula CnH2n plus 2, 2-methyl pentane, 5 carbons in a row, and a side group coming off carbon 2, because it wanted 3 structural isomers of C5H12. 3-methyl pentane is another option. So this is the longest chain here, no matter what. The longest chain here could be along this line, but it could also be along here. So just always bear in mind, can you count in a straight line? Okay, and then the last one was 2,2-dimethyl butane. So again, this could be 4, this could be 4, or this could be 4. So just be careful when you're drawing. I think that was it, and you could have gone with 2,3-dimethyl butane. Anyone have anything else? Okay. So today we're going to look at the Ethene practical. It would be done as a demo, so I will have it set up for you when you return on Monday, and we'll have test tubes of ethene there to look at their properties. When the assignment homework pings, the video link is there for the PDST's version, Declan Kennedy's lovely little movie. You also have the QR code. There is a couple of safety features for this experiment, one of which is, both are important obviously because it's safety, but one of which is really, really important. So we are going to go and do it by drawing the experiment today. Now in terms of when the way they draw this, so you will have a boiling tube or Yeah, it will be a boiling tube, one of the bigger, thicker test tubes, and it has to be at a slight angle. It is never linear. So in some mark schemes you may see it as being in a straight line. That is never the case. At the end of our tube we put in what's called mineral wool, and it's real shiny, kind of fibrous wool. You'll see it on Monday. And we put our ethanol into this. So the mineral wool is going to hold the ethanol in place. It can be called glass wool. So you have the choice which one you want to use, but it is very specific in its job, and it is soaked in the ethanol. So it's going to hold the ethanol in place because ethanol is a liquid. Soaked in ethanol. Okay, in the middle, I'm going to put it up here, you have a kind of an off-whitish powder, and this off-white powder is aluminium oxide. And this is our catalyst. So it is off-white because they like to ask you what color it is, and it is the catalyst. I'm going to change the color of my pen. Now, the SEC, if they ask you to draw this, they're looking for the slight slant, and they are also looking for the fact that you are putting your Bunsen burner directly underneath your catalyst, because that's where you heat for the most part. So your Bunsen is going under the catalyst. And in reality, what happens is we heat the catalyst, we bring it over, we heat the ethanol a tiny bit, we bring it back to the catalyst, but most of the heating is going to be at the catalyst, and it literally is going to go back and forth this way, but stay under the catalyst for the most part. Okay, and the only thing I'm going to add to this is that the tube is tilted. So we then go for our gas collection, and depending on what rates experiments you did in junior cycle, you may have used the collection kit stuff, which is essentially, can be a test tube, it can be graduated, it doesn't really matter, but it is all over water. So these are my little bubbles of ethene, and this is ethene up here. Okay, and the fact that we have the gas and the fact that it'll collect, so literally the gas will push the water out and down, this tells us that ethene gas is less dense than water, the fact that it sits on top. Okay, so it's relatively simple as an experiment. What might be one of the safety concerns that's really obvious straight away? So think about stuff that we're using. Any takers? Okay, so the ethanol is flammable. So you always make sure you have your glass wool soaked, you have the lids on your ethanol, and you have everything connected up before you would light your Bunsen flame. Because if you have ethanol vapor in the air, it will go on fire. So that's one issue, and the second issue I'm going to show to you as a little video. It's a thing called suckback. Are we okay to move off of this? Thanking you. So this is showing you, can you see the share? Yeah. This is slightly different in what it's being used for, but it's going to give you the idea. So essentially what they're doing is they are heating hydrated calcium carbonate or calcium carbonate, it's decomposing and it's going to bubble into lime water and it's going to turn the lime water cloudy. So it's just a test for it. But when you heat something, it usually everything expands. So hot gas at the moment is going from the test tube and it's being pushed into the lime water test tube. This isn't to do with the suckback part, this is just the context of the experiment. So for us, this would be how we're collecting our ethene. So here this gas is turning the lime water cloudy, but in reality this would be us collecting our ethene. So that will bubble away, bubble away, bubble away. And the issue with suckback is that if you remove the heat without removing the tube from the ethene collection, once you remove heat, things contract. So the gas that's in the pipes will contract and it will actually suck water back up through it, and it's called suckback. So you have to remove the delivery tube before removing the heat. So you can see the water going back up the tube, and once it hits the hot boiling tube, if there's any type of, what's the word I'm looking for, fragileness in the tube, it will actually break and explode. So you have to be really careful when it comes to suckback. So when we did it last year with 6 years, I had it all set up so that if it was going to safely explode, it was actually going to be fine. And for some reason it decided to explode the other way. I managed to get Alex. Good times, but he didn't die, so that was always good. Okay, so can never try to be safe enough. Alrighty, so we've done this. I'm going to give you that video link and you've seen the bits here. So the only extra bit that you might like to add in is this part. So by heating the ethanol, it's going to turn into a vapor and it passes over your aluminium oxide and it's going to make you the ethene. Now, can I ask you, if this is the formula for ethanol, we're going to make C2H4, what's the other thing that gets made? So it's kind of like doing funky maths where you subtract your H's from each other. This is a 5. So what's left over? Anyone figure out what it is? It is water, okay? So this will go, it's page 173 for me. We'll put this in there on page 173. So this might be the how you'd write your equation. So you put the aluminium oxide over your arrow because it's involved but it's unchanged at the end of it. So there's two ways. When we start organic next year, we're going to talk about type of reaction that is there. So this type of reaction, there's two ways, and this is going the bottom of page 173. There's two ways to describe it. So the first one is an easier one. It's a dehydration because you're removing water. The second one, not so easy to see. So in chemistry, we have addition reactions. That's when we have two reactants and we join them into one product. There is no equivalent, we don't do a subtraction here. We call it an elimination. So if you have one reactant and you turn it into two products, it's called an elimination. But because one of the products here is water, you can call it a dehydration. So I want to see what you see. So page 173 is what I am looking at. So we have all of the different parts, the roll of mineral wool. So we discard the first tube. Any idea why we discard the first tube? What might be in the first tube? If I just start heating, what's inside the tube before I've ever made ethene?
Oxygen.
Yeah, so air. So there's only air in the first tube. So if you're then testing for your properties, that's not going to be there. Okay, I'm going to change this. Okay, so we have said the role of the mineral wool is going to be to hold your ethanol in place. Because if that is wet and if it gets on your catalyst, it's not going to work very well. It's one of the reasons why we do this as a demo, because it's hard to set up. So the aluminium oxide, it's both a catalyst and a dehydrating agent. And it converts ethanol to ethene. We've said the color of your aluminium oxide is this off-white. So our aluminium oxide is heated. Our ethanol vapor ethanol vaporizes and it's going to pass over the catalyst.
The one you just above the last one
acts as a catalyst. So is the aluminium oxide in your book. It said role of aluminium oxide, so it says catalyst and dehydrating agent. So it's dehydrated into ethene. I'm going to get rid of dehydrating agent and converts ethanol to ethene. So the ethene is collected over water. And this is showing you as well the fact that ethene is non-polar. Because it won't dissolve in water. So it shows us that it's insoluble in water and also less dense than water. Okay, so you let me know when you're ready. Okay, I've got some shakes of heads. Do I have some no's? Okay, so now we're to the part where we discard the first tube. Why? Because it's filled with air. And the last bit are the two safety concerns. So the first safety concern is we want to avoid what's called suckback. And how do we do that? You remove the delivery tube from the water before removing heat. This word, essential. I've seen her not give marks because that word has been omitted. So please make sure that's there. And then the second safety concern is the flammability of ethanol. So you've got to make sure that there are no naked flames. When ethanol bottle is open. So that's where we are going to leave this, because the next part of it is testing ethene to find out its different properties, and we will do that, together on Monday. Very much looking forward to seeing everybody.